Here you have a binomial expression. You're supposed to find the third term of the expansion, also the term with x to the squared and with y to the fourth. Alright, in this case now, suppose you don't remember the pattern of the binomial expansion. What you could do is go one side and say, alright, suppose you have x plus y cubed. This is x plus y times x plus y times x plus y. And then you say, alright, x by x is x squared plus x by y is xy plus y times x is xy plus y times y is y squared, and that multiplies x plus y. Then you say x squared plus xy is 2xy plus y squared. You could see the pattern from there, but you could expand again just to see the pattern more clearly. So you say x squared times x will give you x cubed plus x squared times y gives you x squared y plus 2xy times x would give you 2x squared y plus 2xy times y would give you 2xy squared plus then the y squared time now to multiply out y squared by x will give you x y squared plus y squared times y would give you y cubed. So what you have is x squared plus, alright, you have a x squared y here. Any more x squared y? You have another x squared y here. Two more. So you have 1x squared y plus 2x squared y gives you 3x squared y plus 2xy squared plus 1xy squared would give you 3xy squared plus y cubed. And you say, hold on, if you should put a y and x everywhere, then what would happen is that this x squared would really be hold on, this x squared here would really be an x to the 2 y to the 0, then x to the 2, no, it's x cubed, well, right here, x cubed, x to the 3 y to the 0, then you have x to the 2 y to the 1, and you have x to the 1 y to the 2, then you have x to the 0 y to the 3. So that will remind you of the pattern of the x and y. You notice that the x, the one on the left, the x, the power is the same as this power, and then it goes down one step at each point. 3, 2, 1, 0. Then the one on the right, which is the y, it starts at 0 and goes up until it reaches this power, right? The maximum power. So it's 0, 1, 2, 3. All right. So that's what we have so far. We're going to look at the coefficients, the numbers that multiply the xy later on. But for now, you're reminded that this is going to be the one on the left. The first term will be 2x to the 6, then negative 3y to the 0. It's not positive 3y now, because this can be written as 2x plus negative 3y, right, to the power of 6. So it's negative 3y to the 0. All right. For the second term, this power drops. You have 2x to the 5, and this power rises. Negative 3y to the 1. Alright, so for the third term, it drops further. So it goes from 6, then 5, then 4. So the third term will have 2x to the 4th and negative 3y to the 2. Because the negative 3y power, it goes from 0 to 1 to 2. So this is first, second, third. Alright? So we reach the third term quickly. If it was, say, to the power of 60 and they were asked you to find the 30th term, that would be a different story. You'd have to form a pattern. Right? You'd have to see the first term, the 2x would be the maximum power minus 0. The second term, maximum power minus 1, and so on. Third term, maximum power minus 2. So the 30th term will be the maximum power minus 29, one less than each term. Alright? But fortunately for us with this question, we reach the third term very quickly. But we're not finished yet, you know. This is only part of the third term. We haven't done the coefficients yet. Now remember, the coefficients is a combination. In this case, you have 3 letters to expand. Remember, the expansion was this. I don't want to mix them up. X plus y cubed. You have 3 letters. 3 x's and no y's. How many ways can you combine them? It's C, 3C3. 3 available and 3 x's plus the coefficient here would be 3 available letters but only 2 x's. You're counting the number of x's. 3C2. So you have 3 letters, that's 2 x's and 1 y, and then only 2 x's. Because in our combination, we have available letters and number of x's here. Alright? If you consider the number of y's with the same number, you would get same coefficient. Now 3C2, remember, is 3 factorial over 3 minus 2 factorial. 2 factorial will be 3 times 2 times 1 over 3 minus 2 is 1. 1 factorial is 1 times. 2 factorial is 2 times 1. 2 cancel 2, so it's 3 by 1, it is 3. That's why you get the 3 here. Alright. And so on. So here now. For the third term, which we wanted to find, what you have are 6 available terms. You have 4 2x's and you have 2 negative 3y's. So it's 6c. Let's say you're considering the number of 2x's available. So it's 6c4. Alright? It will be 6c4. So here, if you work that out, you could work it out with a calculator. Alright? So you have 6 factorial over 6 minus 4 factorial, 4 factorial, which is 6 times 5 times 4 times, and so on and so forth. Over 6 minus 4 is 2. It's 2 times 1. But just leave it as 2 to make space. 2 times 4 factorial is 4 times 3 times 2, and so on. So this 4 times 3 by 2 by 1. Cancel this 4 by 3 by 2 by 1. Alright? 2 into 2, 1, 2 into 6, 3. So it's 3 by 5. So the third term, in this case, would be 15 2x to the 4th negative 3y to the 2. And notice also the x and y, power, the terms of the power, they always add up back to the maximum power, the power that you're raising the binomial to. So 3 and 0, 3, 2 and 1, 3, 1 and 2, 3, 0 and 3, 3. In this case, 6 and 0, 6, 5 plus 1, 6, 4 plus 2, 6. Alright. Now, go to simplify this now. 15 times. This is really 2 to the 4th times x to the 4th and negative 3 squared times y squared, right? So it's 2 to the 4 is what? 16. 15 times 16. X to the 4th and negative 3 squared is what? Positive 9 times y to the 2. So you work out 15 by 16 by 9. So in this case, you have 15 by 16 by 9 is what? 2160. So you have 2160 x to the 4th y squared would be your answer. Alright? So ensure you understand the principle behind this type of question.